So the next step, actually, when you select your platform, is like actually you start really the software implementation, so the model development. So on our side, like the model development is the first step. So we're not operating the bench, but we're building the future. How do we will operate the test bench? And the tool that you will selected, the environment that you will selected, need to have some requirement. So for sure, like the more model design tool that you have, like will be make your life easier to bring actually your idea, your concept, or maybe even your code that you already have to a real-time environment will help you. Then after that, you will need to think about the efficiency of the project management. So like, is the platform let me manage all my project, all my needs efficiently? Then the workflow as well for connecting the simulation environment to the hardware is really important. It's good to have a real simulation, but like all the tools that managing the communication and the IO are as much as important as well. So if we're looking at the model design tool, first you want a wide variety. For sure, we have MATLAB Simulink, like as OPAL-RT or others, like it's the main simulation environment because it's well known and well respected. But it's good to know that there's all those sources, all other sources, and like the tool that you select can also support them. So there's the FMU FME as well. So basically a different way to manage like package of modeling. So if the tools can manage them accordingly, that's helped a lot the development. Also importing C code is really important. And we were talking about FPGA. So when you have an SDK, the way that we import VHDL codes, maybe you have expert on your side. Like adding those VHDL code to your environment is really important. So like you need to look the if the simulation actually can manage like different sources and to work together. So basically the goal to have a real-time environment is just not to have one source and another sources that are asynchronous. Sometimes you want to make them synchronous. Like if you want to achieve real time, all those concepts, if you have multiple source in your the final systems, the tool must provide you as well a way to synchronize all of them. So this is really important to ask the question. Then this is fairly common, is like we have multiple suppliers, especially in aerospace. So some of them will say like, okay, we sign an NDA, I will give you my code, so compile it as a library, or at least like give me the way that I can compile that as a library to protect my code. So like the tool should provide you as well a way to protect your code or to protect the code of your supplier or your customers. Also scripting. So sometimes like setting the whole environment is a lot of doing the same time many times. So it's really efficient to think ahead and make sure that the tools provide you some scripting API where you can make probably like automation of some component of building the environment of your modeling. So let's say you have many models, maybe you can have a routine that actually like when you have a new C code that will represent one part of your systems, instead of like doing all the changes and like compiling the library, porting the library to the environment, like make the nice link. Usually those things are always the same. So be able to script them with an API and control the tools through the API to compile, to load, and do everything. That saves you a lot of time in the long run. Uh, like as a young engineer, I start like don't think about that, doing everything manually, and at the end of the day I say like, okay, if I was taking like maybe a day to like set up my my environment scripting at first, I would have saved a lot of time after that. So this is a hard learning when you're starting. And also the model development environment should provide you like a library to actually like achieve real time. This is what we want to get to. So like the tool will probably, you don't think when you build your model as real time, but like usually a tool as OPAL give like will give you a whole tool set to connect everything and actually make real time achievable. There's also the concept of the efficiency of the project management. So it's good to have like an environment when you can have more than one project. So like you can handle many projects. Alex said that first that some benches they actually made for 2 or 3 different ECU, 2 or 3 different projects. So those things in software should follow that as well, and the tool should be able to handle multiple projects and actually have a quick turnover. You want also when you're working, like you want to be able to save versioning, like like you have adaptation, you try stuff, you actually you receive new code. So like having a structure of project where you can actually save as maybe a Git or something like that to do some versioning is really important as well. Yeah, I say that, but like switching to between one to project and then the other should be easy and rapid. So like no much too much programmation, like it should be automatic. So basically in a few clicks you should expect to change from one setup to the other if the hardware follow. If we look at the workflow to manage the hardware, like it is really important. Like so far we talk about the model part, but like next to that, when the model is done, you need to connect everything that's going into the model to IOs, communication buses. So it's really important that you have like an efficient way in your tool that you select to do that. It could be drag and drop, but like when you just drag and drops, it could be it's good for a few signals, but when you have like 1,000 signals, it's not efficient. So like as well, scripting is mandatory here, where you can build a structure where you can like do automation estimation between IOs and your models, especially when your model getting bigger. Same thing as buses. Like if we take airing buses, like I don't think anybody of you want like to manually build it each time. So it's good to have import tools as well. So basically maybe reading a file in XML that define the communication buses that came from you or suppliers, and the tool should have the ability to import those kind of files to save you time. So next step is the bench operation. So once you really do your model environment and you do layer for tests and like you control the bench, now it's going to more like a test sequence. Actually, for a test engineer, like his real jobs after all of that, starting at this point, like we did all of that just to test the equipment and actually like operate the benches. So like this is really the second step and the final step of the life of a design of test benches. So what you're looking for, like at this stage, is like really have a visual and control to your system. So like now we don't talk about designing or developing, we're controlling it. You want data logging. So when you test an ECU, like basically like the goal is to figure it out like something that doesn't work accordingly. So you want to be able to log this data, to record this data, to see what's going on and actually like make the correct correction to your systems. Then for sure, when you have like a nice flow, you want to automate to make some test automation and especially scripting. So you want the bench to operate by himself to run a bunch of tests and actually have a pass or fail report at the end of the day. So if we're looking at the visualization and control of the HMI, so you should ask yourself, what is the minimum widget that you want? So what kind of button and like scope that you're really looking for? Are you looking for a scope that only have one curve, two curve? Um, it's pretty basic as question, but like like it's good to plan ahead, like to when you make the right selection. Did the tool that you use have all the plan widget? For example, like a lots of you want not only like visual interaction, but they want to incorporate maybe a mock-up of their airplane and with like small details as valve. And if the controller open a valve, maybe you want really like a drawing of the valve getting open or closed. It's really visual. That will help like more like an operator to see what's going on the bench. So adding those higher feature is really useful. Uh, like especially for the visualization, we should be able to manage the real-time data flow. Like let's say you run at 50 microseconds, like you would generate way more data than actually like you can see through a higher level HMI. So like like the system should be able to manage data flow and actually like according the visual aspects of it, and actually you should be able to zoom in, zoom out, and see the real systems. Something that we don't talk but is really useful is like when you control, like especially when you're doing tests, like having the feature that is not just pressing a button, but maybe you can like press multiple parameters in the system and actually launch the command on them as a parallel command. So basically, if you have like you want to set up temperature, altitude, speed of the airplane, but you don't want to change them as a human like one by one. You want them to be started at the same time. So basically, having an HMI that lets you like programming all of them, and then after that launch the sequence to actually send them all together is really important. And also ask you yourself, like, do you want an operator or developer mode? Like, do you want the operator to have access to the whole same environment of the developer? So some HMI will actually let you like having something like standalone. So basically, you can build at first the environment for an operator where he can have just his launching script, managing the bench, but without doing any modification to the real environment. So this is a question that you should ask yourself as well. And is really efficient if you can change and add stuff to your control and visualization during simulation. So you like if you're a developer, like you miss something, like doing those kind of development during simulation save a lot of time as well. If we go into the data logging capabilities, like it's for sure like having the recording function is mandatory on all test benches, uh, because like you want to monitor a lot of different signals, and if something happened, like a fault comment from the ECU, you want to see like what is the sequence of that going on. So you really want to be able to record all the simulation data, like the virtual one, everything that's going on the COM and the IOs as well, and as well all the commands, special commands, but everything that's going on the HMI. Then also like recording should be adapted to different resolution. What I mean by that is if you're running a model at 50 microseconds and you have like, let's say like 5,000 parameters and signals that you want to record, those files will get really, really, really big. So you need like a flexible recording that actually can change recording rate. So maybe like a temperature, is it mandatory to record that at 50 microseconds? Maybe not. So like having a flexible tool that give you like different recording rates is really important as well, because or if you don't, like you will end up with like gigs and gigs of data that actually not that useful. Time tag is always important. So you can have the time tag of the simulation, but just keep in mind that some of them, especially in the run birds, they want like to have multiple bunches that record what's going on, but they want a common files at the end. So basically like different sources. The best way to synchronize that is to synchronize the systems to an external time source, like a GPS signals, or there's like an emulator that we can find in labs that will generate a time tag across multiple benches. So make sure that we can have recording that actually is tagged to maybe an external sources of time as well. That could be useful for the future. If we go into the test automation, um, for sure, like having a software tool embedded, like or supported by the tool that you select as an iTest10, for example, it's really an easy way to actually build your test sequence and generate reports. Also, like having the flexibility of more maybe like a more open scripting, like API, like Python's, C, like having an API that can control the benches, like give you like the full flexibility if you want to go to these directions. It's like the script had to be able to be called during simulation. So the script should be able to control two things if you're going to an API. Like either during simulation to change parameter, change values, recording values, and stuff like that. But also you want an API that can control the whole bench as an operator. So like start, stop sequence, change parameter before loading your models. So you're really looking for a complete API there. And for sure, like both tools, it could be API or a more proper test automation software. Like the end goal is like to generate reports for your systems. If you're looking at something that actually like we do internally for customers is like we 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 help the customer because we know the model getting really huge fast. So like we propose some like like quick modeling aspect where we have like such like be a trim. We call that a trim blocks there. The trim blocks actually is really neat because it's just like looking at the name of the signal in the simulating, for example. And then after that, it will define automatically all the names. So actually, we'll create like the name of the signal with a trim at the end. So like it's getting like a structure of naming in the models first. Then after that, they give you like calibration features. So basically, give you a gain and a bias. So now it gives you value automatically as calibration, and this could be like called by a script if needed, or from a timetable or exporting. So we can do a lot of things in there. And then as well, like it gives you like a way to either use what's going in, like getting the input, calibrate, and getting out, or you can actually like make like a like bypass it, like like a force a value. So basically you disconnect the input and manually you input like a false value. So it's kind of a way to test and actually generate fault as well. So the block structure is kind of simple, but at the end as well, we develop script for that. So basically, this block is automatically scanned in the models, and automatically every time we compile a new models, like those kind of subset of Python script from our API will generate like a report and create aliases, so like a unique name value for each signals in the models. So when you have this table, which is really neat, after that, you have a comprehensive for an engineer's naming, which is unique in the model, where you can actually like call some bias gain and actually like do some fault or actually even bypass the value. So like that's give you really a dynamics environment of works. Plus, we had here some report that actually if there's two signals with the same names, they will call you like an error detail. So basically, you can find where this name issue is in the model. So that gives the developer like a really neat tool to be efficient and actually like work really well. So this is just an example of scripting that we typically do for in such benches. So now is the time to conclude. So the OPAL-RT mission is like really to optimize and reduce the test effort for complex electrical and mechanical systems. So basically build test bench or like provide new solution for that. So at first, OPAL-RT is really a company that builds simulation. So we want to build an affordable and cutting edge real-time simulation. So like our first offers is really our simulators naked. Our simulators are based on CUTs, like commercial off-the-shelf technology. So basically, we try to use them more and as much as we can, component of the shelf to be really performance. And actually, we are really flexible in our offers. For example, we use Intel and standardized motherboards, like really ruggedized one, but like actually something that we can find on the market. That's allow us to update our CPU line kind of really fast, like every few years. And so you always have the best performance that you can find on the market. Same for our faster controller as FPGA. Usually we work with company that provide like an FPGA where we just follow a pattern and we can just swap the FPGA, adjust our tool a little bit, and we are really efficient into that. Then after that, we're going to more services that maybe Alex, you can talk about your group.
Yeah, for sure. I'll be quick on this. Basically, what you've seen it so far is something that I've been asked is it possible to do it in house or can I do it myself? And the real answer is yes, but OPAL-RT, as other companies, has a specialized team to be able to support you with that and to go along with what needs to be done. So it's something that you've seen that showed in the slides that we have. And I want to thank Mathieu, if you can go to the next slide. Basically, thank all of our customers that were actually kind enough to work with us and help us build the knowledge that we have today so that we could give you this presentation of the details of doing your own test bench and testing your own ECU. So thank you very much to all also that were present, even though we went a little bit overboard.
Yep.
Thank you very much. So right now, I think we would go to the question
Question
period
phase.
if
Yeah.
there's any. Yeah.